But then a time came that we evolved into things like chatbots using natural language processing. So with the natural language, we're able to build chats where we converse with the AI. You operate on predefined scripts, respond to the input, but lacks independent decision making. So normally, if you ever used website, you will see something will come up and say, hello, how can I help? Then you tell it and say this, then it should at some point it will tell you, I will transfer you to a human age customer or something. Then later on, it's a human, this thing will pick it up. So usually that kind of things you see on the website, they are just built with simple natural language processing inside the website. So by the time it helps at some point, it will connect you with the human agent that will take over from there. So well, what that means is that the agent can only, be able, the chatbot can only just handle some simple things that are not really complex. But then we came to an era of things like the ChatGPT, Google Gemini, DeepSeek, Perplexity, and all that could help us do so many of those things, such as they were acting as a co-pilot sort of assistant. Now, when you know what a co-pilot is, if you've ever entered inside a plane, you will know that the co-pilot is always besides the main pilot, and it's always, helping the pilot on how, for example, things like map reading, things like picking up signals from the control tower and all that. Then the both of them will be navigating and making sure that the plane lands safely. So that's how this ChatGPT used to do. So normally you give them a prompt and then they will assist you. They will give you some sort of recommendation. They'll get back. They will do that. So it's much more intelligent than the normal chatbots we used to have. So it provides recommendation and assists decision making, completely reliant on human prompts to act. Truly, if you interact with the ChatGPT, you know that you have to type something first before they can be able to know what you want to do, and then they guide you through. But now, in the agentic AI era, it is an extension on these ChatGPTs. So in the agentic AI era, we kind of reduce the human involvement. So we now have autonomous goal seekers, AI agents that are seeking, for example, one AI agent to handle data processing, another one handles visualization, another one handles modeling, another one handles interpretation, and then another one will handle reporting. So that's like you bring different large language model, and then you create those things. So it's characterized. How you know that it is self-directed in decision making, dynamic problem solving, and tool execution. So a good example is that prison that I showed you guys the other day. The agentic workflow shifts systems designed from fixed pipeline to a dynamic graph. So in the agentic AI era, whenever you have the problem and you ask the AI to look at your prompt template, for example, it looks at all the things you have done. So just like a human being or a researcher, it will pick all these tasks and break them into smaller tasks and also get all the tools that it needs to fix it. For example, as a data scientist that I am, each time you give me a data and your hypothesis or your overview of research that this is what you want to achieve. So what I do is that I take a look at the things you give me, then I begin to think about in terms of, first I try to understand your research, I try to understand your objectives or your aim. Next, I try to understand your hypothesis and your research questions, and then I looked at all the objectives you have listed. The next thing I'm going to do is now to think of how I could pull material, either to consult literature to understand what has already been done, how it can be done. By the time I understand that, the next thing I'm going to do is now say, okay, let me familiarize myself with data. So if you don't have a data, I will now think of, okay, what kind of data do I need to collect to address what you are doing? Then if you have the data, I would looked at the data that you have collected, and then I'm going to see how I'm going to utilize that data. So what I'm going to do now is, okay, since I now have the data, I need to also look at Python. So if I'm using Python or R, I'm going to say, okay, this is the software I'm going to use. The same way the agentic AI break down all those tasks. So just like in the traditional normal machine learning process, we have the input, processing, model interface, output. So it is a fixed pipeline. It doesn't change. Once I get the data in CSV, Excel, or PDF format or anything, I feed it to the AI algorithms. I process it. I make some visuals or convert them into some sort of tokens, and then I output, and then I make my decision. But in the agentic AI era, some things are very, very important. First of all, you will look at the tasks. So you break down these tasks to different sub tasks. By the time you break them down into different sub tasks, the next thing you will need to do is to look at which tools you will need. So let's say you have set of 5 objectives. All the 5 objectives will be broken into different sub tasks and assigned to different AI agents. Now, I will say agent A, your task is to get all the tools that we need to visualize this data. So the agent A will know that what it needs to do is to go and get Python, is to go and get pandas, is to go and get skitlearn, is to go and get Seaborn, or is to go and get matplotlib. Its own is just to do the visuals. Then agent B, your own is to analyze or model all the variables of interest. So agent 2 will just focus on that task. Agent 3, your own will be to assess what has been done. If any error pops up, report the bug and fix it. Agent 4, your own task is to pick it up from there and judge all the analysis. Agent 5, your own is to fetch literature for me. It gives all those tasks assigned. Now, if you looked at this whole thing, you will understand that normally you cannot be able to achieve that if you don't want to reason. So the reasoning will be what will guide them, the tasks to be broken down into sub-tasks. The reasoning will be another thing to guide you on which tools to set on to guide the AI agent in this case on which tools to select. But in all this, you need to have a memory. Because if you don't have memory, you will not remember what to do. Remember when you are writing exam as a student in a classroom, you first of all read to prepare for the exam. Then when you get to the exam, you write and solve the problem in the exam based on what you have read. So your ability to remember what you have read and to be able to use it to translate into solving the problem you are encountering in exam, that is the process where learning actually takes place. Because you don't even know if you have actually learned something if you don't actually put it into solving something. So that's why I used to say to people that you need to begin to think in form of input and output. Because when you are thinking that way, then you begin to have a reason why you are doing something. So if you are reading, for example, why are you reading? Okay, you are reading because you have an interview. Great. Then the next thing is now for you to tell yourself and say, okay, this interview that I have, what area am I supposed to focus? Maybe you need to focus on the managerial aspects. You need to focus on what the company produce. You need to focus on who are their customers. You need to focus on some of the services they render. You need to focus on how their financial whatsoever is moving. So by the time you know all these things, once you go to face the HR team, they will now test what you have known. So they will, of course, they will assess your experience, they will assess your skill, they will assess what you also know about them and all that. So the same way you have that ability to remember and to answer them accurately, that's how the agentic AI system is built. It has a memory. The memory will now be where you are going to store the tools that you have gathered. The memory is where you also will be able to assign the tasks that is very important. The memory is also very important because that is where you also organize the reasoning. So that memory, without it, the AI will forget. Now, if you are prompting with ChatGPT and the rest, most of the time, for me, most times when I chat with these things, sometimes when I come back, I'll ask it if it remember the previous chat. I'll say, did you remember what we have been talking about previously? Then it will tell me this, and then sometimes I'll have to make sure it's remembering the right thing. So I'll say, this was the chat we have been talking about. Can you tell me more? Then when I see that truly it remembers, then I'll continue with the chat. I'll say, okay, do this for me like you have done previously, stick to that and all that. So the same way, the reason why the ChatGPT could remember is because it has a memory where it's storing our conversation. So if you meet somebody before, you don't need to try to remember that person. For example, I've known Nandi, so I don't need to struggle to, even if I meet Nandi in the next 10, 20 years, I know I already have him. So the knowledge of Nandi has already been stored in my memory. So each time I meet him, it's a continuous thing. I wouldn't have to say, "Oh, do I know you?" And no, because I've already known that person. So that's how the agentic AI behaves. It has that memory, so it could be able to remember and organize these things systematically. So if you looked at it, you will see that this process is not a linear process. It's not like a process that goes from this, but it's moving across. All of them are cross-talking. The memory, the tools are cross-talking with the memory is talking to the task is talking to the tools are talking to the reasoning, the task is talking to the reasoning is talking to the task, and also the memory talks to the reasoning talks to the memory, and all that. So it's a back and forth process that is dynamic in its orchestration. So it uses reasoning engine, break down the goals, select the right tools, and evaluate the result and adapt strategically. Now, you will also get to see that they have a very big difference between the way the normal AI reasons and the way the agentic AI reasons. First, their architecture, I've already shown you in the previous slide that they are not linear in nature. The non-agentic AI, it has a fixed pipeline with predetermined component, while the agentic is dynamic in the orchestration with a reasoning engine and tools which it uses for selection, how the decision making are made. Basically, the non-agentic AI make decisions based on execute predefined logic or pattern that they have learned from the training data. But in the case of agentic AI, it uses reasoning through the problems and adapts approaches to achieve an open-ended goal. Because of course, the prompt you are giving to it is open-ended. So what it's going to do, it will reason just like a normal human being would do, and then it will answer. So here is it now. The fact that the both of us are writing the same exam does not mean we will answer it the same way, except if we are copying from each other. So the way I remember when I was in the university during my undergraduate, two of us graduated in my set with first class, me and Spo. Now, the pattern in which we answer questions is usually different. Spo is this kind of person that he doesn't really like long explanation. So you see him, he writes short, and he's done. But me, on the other hand, I like to elaborate. So you see me, I elaborate on something. So maybe when you looked at our solution, you will see maybe Spo's solution takes 5 lines, then maybe you looked at mine, you see it takes 7 lines or 8. So at the end of the day, we both get maybe an A, but we're getting it from different approaches. So it's very rare for you to see us using the same pattern. So the people that I teach, most of the time, I tell them, I say, stick to my material, because by the time they go and use material from SPO, then they get confused. And then they will come back and say, Onoja, I don't know, but I'm failing this. And I'll say, because you get yourself confused, you have to make sure you stick to one area so you could be able to master that pattern. So it's like a teacher having different disciples. So by the time you hear from this person, you hear from this person, you see you get yourself confused. There is a Hausa proverb that used to say "Sakasaki aljanna kare." It means that in between is the paradise of dog. You are not here, you are not here. It's kind of it gets you confused. So the
So you
agentic
still
AI
remember this?
using, oh my goodness, I cannot forget Hausa. I speak Hausa. I think Hausa is much more easier for me to speak even than my language, Idoma. So I
Yeah.
could easily, there are some things that I see them, I know the Hausa name. but I don't have the Idoma name. I have to maybe think before I will get the Idoma version of it. So Alta is more like a follow come. All right. So you discover that the reason through the problem is what makes it to be unique because it can adapt. So the moment the agentic AI try this route and it fails, it can go back and retry another route. So each time you are doing, you see sometimes it runs into a bug, and then it will ask you, do you want me to fix it? You click it, go back and fix it. So that reasoning is what gives it the leverage to go back and forth. Now the scaling, it discovered that the non-agentic AI is very linear in the scaling. Lower cost per inference means it doesn't really take much memory. It's the computational cost is not there, but the non-linear, of course, it's going to be higher because what you need to understand is that there is what we call the MP problem in computer science. That MP problem is always talking about the computation and that and memory. So each time we are with the more complex the model, the more expensive they, because in the computer world, how we think in terms of memory. So each time we are running a model, for example, regression. Linear regression takes a very small byte compared to decision tree. And then when we now scale it to, I don't know, if you do future selection, for example, you will know that we have three kinds of, I think in the previous classes, I did teach you guys about future selection, where I said that we have three kinds of future selection. We have that future selection that it's basically looking at relationship, it's basically looking at associations, things like chi-square, correlation, and and all that. They are very easy. Select k-best, all these kind of methods, they are very easy. They don't take much memory. But then there is another one that we have that uses the grid search approach. So it means it's going to fit a linear sort of regression around each of the future, and then it will look at the coefficients that are important, and then it will drop them. So it can be forward selection or backward sort of recursive selection. So it means recursively, it's going to go back. So if I have thousands of futures, you can imagine how long it's going to take to identify the ones that are very important. But the good part is very, very nice because most of the time it will drop all the other features that are irrelevant in my model. But now the problem is the amount of computational cost is going to take. It will not be funny. So if you have 400 features and then you do not have a large computational memory, it will take almost maybe a week for it to go over and return back the results for you. So that is one of the way we think in computer science. We always have to think about that computational cost. So imagine when you are talking of this agentic AI, where you have some of this kind of problem, the computation is non-linear, it's exponential in the scaling, and the cost, of course, will be higher due to the multi-step reasoning loops. Then the failure modes. Now, it is easily predictable. You can use the confusion matrix in the normal traditional ML, or you can use the standard errors to be able to see what you are getting correctly and what you are not. So the misclassification or out of distribution error is easy for you to see them and actually predict them. But in this case, tool misuse, reasoning errors, cascading decision failures, and non-deterministic bug can happen, and sometimes you will not know. And that's why we talk about hallucination a lot when we talk about things that has to do with large language model. You see us, we keep talking about it. And that's why we continue to insist that you must keep human in the loop, because you can hand over the AI agent complete autonomy because of some of the fact that even if it misuse something and you are kind of focusing on the high risk domain area like medicals or healthcare, and where you are looking at areas like military, you are looking at other areas like finances, these are sensitive areas that anytime you misuse something, it comes with a cost, and that cost could be very terrible. For a case of medicals, it may involve human life. Maybe the AI agent was supposed to put the right combination of drugs, and it doesn't do that. It mistakes that, and there is no human agent in the loop to be able to account for this and mitigate that error from that risk of error from happening. It could cost life of humans. And then in the area of military, for example, most of the nuclear warheads have to be left, the decisions have to be left with human beings to do. Now, in a situation where we are continuing to see global tension rising, I saw this morning that North Korea attacks Japan with some ballistic missiles. Now, you can see the tension is high. If we don't have humans that could be able to regulate these things and we automate this process, even when the AI detects there is a forced invasion, the AI could easily just react, and that could go a long way. I think when you do algorithmic accountability in machine learning, I think I did some courses during my PhD. You will see one of the stories that we talked about was during the Cold War between the US and USSR. There was a period that there was this submarine commando that he thought the US were coming to invade the Russians. So he almost the signal he got from the system made him believe that they were almost coming to attack. So he almost pressed the button for the nuclear warheads to go off. However, what saved him was to call. He used his initiative to initiate a call, and when he called, they discovered it was a false alarm. There was nothing like that, and that was how he halted the process. Now, you can imagine if AI was the one that was handling that process, and there is no human being, the AI could easily just go ahead and order for a strike, and that could have led or spiral into a very big conflict that would affect the entire globe. So that's a situation where you are not supposed to leave the whole of that system entirely to AI to handle. Another example in finance is, in the financial world, one of the things you have to keep dealing with is how to predict if a stock is going to fall or is going to rise. Now, imagine where you have people giving their money and everything and trust to you, you know, expecting that they are going to get a profit, and then you copy the whole of that particular trade or something and hand it over to agentic AI and say, okay, you do that for me. Now the AI will predict maybe that this stock A is going to go up in, let's say, in 2, 3, 4 minutes time. And then you now say, oh, it's really, then you invest the money that you have. Then in 2, 3, 4 minutes, something unexpectedly happened, like a US attacking Iran. And then you didn't see that coming. And then because of that, everybody, refused to buy that stock. Now you don't have invested in, because you hand it over to AI, who have gone ahead to order the for you to buy that stock. Now an unexpected event was triggered, and then it causes a global shutdown or global economic recession, and then you see that you lose, and that becomes a very big problem. So you have to always be having human in the loop, so human can be able to help to override some of these decisions, so the AI doesn't just make it on its own. Now we have a debugging approach. So reproduce with same input and check the model prediction. It's always very easy for you to check what's happening in the non-agentic AI systems. You can easily just get the data. You follow the same written down metadata that have been established on how the model was trained. You can reproduce it, and then you check what is happening. But in the case of the agentic AI, you need to trace all the multi-step reasoning chains and analyze the tool selection logic. So it becomes more difficult and complex for you to debug an agentic AI system. So an agent is a reasoning engine surrounded by interactive models. So now let's look at why we said it is a reasoning engine. Now, on top of it sits the brain. The brain of the AI agent is nothing but the large language model. So it could be a Google Germain, it could be ChatGPT, OpenAI, it could be a DeepSeek, it could be Perplexity kind of model, and all that. It could be Anthropic, it could be many of them, you know. So we have this autonomous framework that orchestrated that give out or those are the triggers that manages the multi-step workflows. It monitors the progress and adjusts the action based on feedback. So there's always talking between the large language model and these autonomous frameworks. And then we have the memory systems that transform a stateless LLM into a persistent agent, a short-term active context, and long-term stored knowledge. So the memory acts as a retrieval and also as a storage system. So if you are familiar with RAG, retrieval augmented what again? RAG, retrieval augmented generation. That's what we call the RAG. So in same way, the RAGs work, by where we retrieved an information from a database, we vectorize it, and then at the end of the day, the user can interact with it. But it's somehow the same. So in this case, we have the memory where it transforms a stateless LLM into that persistent agent. So it helps to retrieve contexts that are within a short time and also the ones that we have stored previously. Then also again, of course, the data. Then we have the tool registry. Now the tool registry is now like the front end where we can be able to interact with it. So it is the AI agent's hands, or like just like a normal human being have legs and hand. So the tool registry are the hand of the AI agent. So they are that one that gives the AI the external capabilities, for example, to search the web, to speak to an API or call an API, and also to perform things like code interpreters. It allows it to surpass the parametric training. So in other words, the tool registry is what helped the AI to connect back to the world or to the real world. Now, the tools used and the reflection pattern create iterative self-correcting loops. So let's look at the pattern one, the tool use loop. So the user sends a query and the query gets to the LLM node. The LLM will now break it down and select the tools or communicate to the tool selector, and also the tool selector from this hand will be either it's going to talk to an API or it's going to talk to a database. When it gets the right information, it will return it back to the selector tool, and then you now get. So the whole thing again is this: if the user sends its query, the LLM nodes can make that process by communicating, and this will go back, and then at the end of the day, it will return back and gives you the final output. So it enables dynamic interaction with external system, bridging the gap between the static training data and the real-time reality. Now, this one, in this case, this pattern one is just for you to tell the LLM to, and for example, if I have a data and I feed it to the agentic AI and said, I want you to analyze this data for me. Now, what the AI will do is for him to go and assemble all the right tools. It needs to get Python. It needs to get all the packages in Python, Pandas, Seaborn, all that. It gets all the right packages that I need. And then also for it to do that, of course, it will call the skitlearn APIs. It will call the pandas API, call all those things, and then it will process them. By the time it do that, it gets me the final output. But then in pattern two, there is what we call the reflection loop. So in the reflection loop, it is a self-critique sort of where you asking the AI to not just process this thing and give you no, because the AI could run into risks of hallucinating. So because of this issue around hallucination, you do not want the AI to just give you something that is not true. So you ask the AI to scrutinize what it has produced. So that's one, most of the time, you won't give this first LLM node to do that. You will likely give it to another LLM node And then that LLM knows, for example, this final output here will become an input for it. So it will now go into this node here, and then the LLM here will scrutinize that output. It will self-critiques it, return it back again. And once it is satisfied, then it will pass it on to the final delivery. So it is a structured self-review loop that improves the factual accuracy and standardizes the response without human intervention. Now, there is what we call the interleaved decomposition, allowing agents to recover from inevitable failure. Now, the thing is this, you have to decompose them, because the more complex your query is, the more you confuse the AI. So because of that, you make sure you break it down into sub-tasks. So what we do is, the goal is maybe to analyze analyze competitor price. So there is going to be what we call the planning node. The planning node is going to break it down into sub-task 1, sub-task 2, and sub-task 3. Now, when it breaks it down into these sub-tasks, it will now start going over them. You can see, let's say task 2 get a problem because it couldn't communicate with the API. The API was dead. So there is a missing data here. So we will now find a way. Once, let's say, task 3 is done, we can shift that particular task to it, because that node has now died. So we need to maybe take it to another node, or we will wait for that node to come up and we will still see how we could call maybe another API. So this is a typical example of what we call the plan, ask, reflect, repeat loop. By separating planning, execution, reflection, the AI agent handles the dynamic uncertainty. When an initial approach fails, the agent will pause, reflect on the error, and adjust its strategy, mirroring the human solving problem approach. So it means that once this couldn't communicate better, or once this node here is there, the AI will find a way to handle it. Either it will wait for this subtask 3 to be complete, it shifts this subtask 2 to it, or it will shift it to 1, or it will send another call again to another API. Now, there is again what we call the multi-agent patterns that divide complex workflows into specialized roles. So in this case, it is not one agent that is handling everything. Rather, we have so many other agents. So we have the managing orchestrator. So the managing orchestrator is like the whole organizations that you now have. So in each organization, you have different departments. Let's say now in a typical consultancy firm, you have the researcher, the analyst, and the reviewer. So there is an agent that will, what it does is to connect web and database tools to pull literature, scrutinize the literature, analyze the literature, identify thematic themes, visualize some of these patterns, and then summarize and tell you what it has gotten. Now, that is a typical, it will perform all the roles that a typical researcher was going to do. Could analyze those, to analyze the data, get the literature and all that. Then we have the analyst one. Now, the analyst one, once this data is gotten from the researcher, he will pass it to the analyst. Now, the analyst will connect to the code, interpret it, run all the modeling phase. Now, once it's done with the result, we'll now have a reviewer. The reviewer will connect it to policy, connect it, with all the existing frameworks that are out there and see if what it has done is in line with, for example, literature. So the key takeaway here is separation of concern, preventing a single LLM from collapsing under massive context window. Because the LLM do have a particular context window that it can take. I think Google can take up to 1 million tokens, and ChatGPT, I think, could take up to 600 or 700,000, and so on. Now, the issue again is once the context becomes so large, there is what we call lost in the middle phenomenon. Now, that lost in the middle is that as the AI tries to read all the context, before you know it gets confused, it forgets the ones that it has read. And then you see that the AI will now start giving you half information or vague answers because the context is so large. So sometimes we tell people and say, make the context to be very precise. Now, imagine when you need to summarize the whole complete task, which is very much, it's not going to be easy for the AI to remember everything. Let's say you are looking at a book that is maybe 600, 700, 800, 1,000 pages. That's quite large. And you want the AI to look at it. So sometimes you can get lost in the middle. So, but by splitting them into chunks and assigning different AI agents, it helps you to overcome that context issue. Parallel execution. Now, if you understand how parallel helps us in the GPU parallelization, for example, is most times when we have a lot of computation issues, we're trying to assign them to different GPUs. So that way, all of them will run them in sort of quantas format. That quantization of those particular work will make the computation to be faster. And then at the end of the day, you can be able to solve that problem quicker. That's one of the advantage of things that like GPUs. So that sort of micro agents operate sort of as in a synchronized way, and then it drastically reduce the latency because most times when it's much like that, the computation will become so expensive. So when we break it down into different tasks, it's like we are quantizing them. And then the clear ownership, the orchestrator owns the final goal while the work operates strictly within the defined constraint. So by giving them to different sub-agents, we're able to get everything harmonized. Then at the end of the day, the orchestrator will manage everything together. So the open source framework dictate how you orchestrate and scale. Now, what are the open source framework that are available for us out there that we can be able to build AI agents? The first one that is very much popular is what we call LangGraph. The LangGraph is complex workflow that has strict states for management. We use them for production grade scaling, and it reduced resolution time by about 80% for Kalana, 85 million of users. Now, this LangGraph, when we enter maybe the practical section of this AI agent class, I don't think we'll do that today, but we will see how we'll be able to do that. We can assess them, and then I'll show you how you can get those things. But it's not something you can easily get them only in your computer because sometimes the packages are kind of much. But I think LangGraph is something, of course, you can get it installed in your system. Then we have the CrewAI. The CrewAI is role-based teamwork with clear hierarchies, in streamlined business automation and robust task delegation. So it's also very. So I think these are the two that I'm quite. Oh no, I think the three with Pydantic AI. I think they were the three that I'm familiar with. But then we have this the semantic kernel is enterprise integration .NET environment. It helps to produce stable production-ready system tied directly to Microsoft 365 and Azure ecosystem. And we have the AutoGen, which is research-focused multi-agent conversation. It helps in prototyping, dynamic interaction patterns, and experimental architecture. Then we have the Pydantic AI, is type safe output modeling data validation. It eliminates LLM unpredictability in environment requiring strict data schema. So I think that's why I'm kind of familiar with it because I've used it before when I needed to produce some data visualizations with LLMs. Now, agent security requires a multi-stage defense in-depth pipeline. Now, you need to understand that because of the autonomous part of this agent, you get to realize that you need to be very careful because this can become vulnerable. There's what we call prompt injection. Now, it means that somebody that can easily manipulate the agent in order to become to serve their malicious purposes. So because of that, you need to put the security in place. Because if you don't put the security in place, someone else could, take advantage of the vulnerability and use it for his own or her own evil purpose. So we have the input validation, the execution arena, and the output. So you can put the security in during the input validation or execution phase or the output phase. So before the model, normalizing input validates intent against user's role and detect prompt injection or jailbreak attempt. And I'm going to tell you guys things about jailbreak. I hope I can be able to create a class to talk about some of these things in detail. Now, what happened is that when we talk about this prompt injection, it could happen during when they are developing these AI agents. You can put a hidden command. You can put a metadata or some sort of a prompt inside it and tell the AI that this is what you want it to do. And even when they deploy it and somebody takes it, the AI will now quickly start working against you. Now, for example, there was this guy I read some weeks back that created his own AI agent. What the AI agent was doing, it's in form of arts. So once you download that art, the moment you download the art will start crawling sensitive informations like API keys and all that, a bank or ATM sensitive informations, because most times people use their systems to make payment and they save the card information on the system. So when you do that, it will quickly go and start crawling some of the sensitive information, and the guy can have access to all those things. Now, so you could inject it during development, and you could also perform prompt injection even on the AI itself during prompting. So during prompting, you can easily hide that sensitive information. You can put something and then the AI will not understand. It will lose guard, like Nigerians will say, and then it will be able to carry out the malicious purpose. Then when we talk about jailbreak, on the other hand, we're trying to make the AI to do what it's not designed to do. So we begin to tell the AI, for example, you see somebody come and said, and said, how would you advise someone that wants to go and rob a bank? Now, the person didn't say he wants to rob a bank, because if the person said he wants to rob a bank, immediately the AI is going to shut that person out and say, no, I cannot do this. So when the person comes and turn the prompt and say, how would you advise someone that wants to this? Or maybe it's something that has to do with biological weapon. Maybe the person wants to build a biological weapon that he can use it to harm people. Then the person comes and says, as someone is building this kind of things, how do you tell the person what to and what not to do? You see, it will trick the AI to give him that information, and then the AI will believe that it's not breaking the rule. But in real time, the person is actually trying to jailbreak it to reveal things to him that he can use it against others and do out for some malicious purposes that are not right. So during the model training, there's what we call the sandbox environment enforcing least privileges. It validates schema for tools, calling and preventing server-side request forgery. So the sandbox environment will help to be, looking at some of these schemas and the tools that are being called by this AI agent and see if some of these tools are not going to do against the wish of how the AI was designed. Now, after the model, data loss prevention, block PII leakages, and groundedness check ensure the claims are supported by retrieved sources. So of course, I always used to emphasize that you don't just take everything that the AI gives you and go into work entirely. You have to read the things that you get from these sources. You have to ensure the sources exist. You have to make sure that the AI result is not hallucinating. You have to make sure whatever you are giving out there is not just fabricated. But if you don't, you have to check and ensure that these things are safe, because the AI too make mistakes. And also sometimes, of course, it has inherent bias. Is there any question so far? Any question?
Not on my side yet.
Okay. So we have high risk action demand as two-step commit